So if we take the equation x minus 3 squared plus y minus 2 squared is equal to 13, let's think about the steps we did yesterday in reverse. Okay, what did we do right before we got to this step? Or what did we do to get to this step? We factored. So the opposite of factoring is to multiply it out. So let's do that. Let's square x minus 3. So that's x squared minus 6x plus 9. Don't forget that that really means x minus 3 times x minus 3. And do the same thing with y minus 2. If we multiply that out, that gives us y squared minus 4y plus 4. And that's, of course, equal to 13. Okay, so let's think about where we were at before we got to this step. X squared plus y squared came from the r squared, so I'm just going to pair those together. I'm just going to write those so they're in close proximity to each other. I'm going to leave the negative 6x. I'm going to leave the negative 4y. 9 plus 4 is 13. And that's equal to 13. So if we subtract 13 from both sides, well, that goes away. So now we are going to use those relationships that we've been using. X squared plus y squared is equal to r squared. We have that relationship right here. We use different colors since I'm starting to substitute. X squared plus y squared is equal to r squared. X is equal to r cosine of theta. So in our equation where I have x, I'm going to replace that with r cosine theta. Y is equal to r sine of theta. So where I have y, I'm going to replace that with r sine of theta. And this is equal to 0. Now, if you remember those equations, the very first step that we took was we multiplied everything by r. So the opposite of multiplying everything by r is to factor out an r. All of these terms have an r in them, so we're going to factor out an r. Okay, so it's kind of we have an equation right here. We have an equation. So remember, whenever we're solving equations, if we set them equal to 0, or if they were equal to 0, when we factored, we set each of our factors equal to 0. So r is equal to 0. That means it has a radius of 0. Well, it's nothing. That a radius of 0 doesn't mean anything. So our equation here is r minus 6 cosine of theta minus 4 sine of theta is equal to 0. And it depends on how the answer choices show up. A lot of times it was r equals. So technically we're moving these things to the other side, so we would add them. So r equals 6 cosine theta plus 4 sine theta. R equals 6 cosine theta plus 4 sine theta. That is our final answer. You could, of course, confirm that in Desmos by graphing the original, looking at that circle, graphing the polar equation, and just making sure that they produce the exact same circle. Okay. Any questions about any steps that I took along the way? Again, I'm framing it from the reference of I'm just trying to do all my steps in reverse of what we did yesterday. Okay, let's look at another example. 3x plus 5y minus 2 is equal to 0. So this one's not going to be a circle because it's not x squared and y squared. This is the equation of a line. Let's go ahead and jump to substituting. We have expressions for x and y, right? X is equal to r cosine of theta. Y is equal to r sine of theta. Now, just like we typically solve for y in rectangular form, in polar form, we usually want to solve for r. So we're going to do that. We have two terms that have r in them. So let's move the term that doesn't have r in it to the other side. So we'll add the 2 to the other side. And since both those terms have an r, let's factor out the r. So we've got r times 3 cosine theta plus 5 sine theta is equal to 2. And if we're solving for r, we would divide by what we're multiplying r by. So the 3 cosine theta plus 5 sine theta, divide both sides by that expression. So r is equal to 2 over 3 cosine theta plus 5 sine theta. So again, another example of where equations that tend to be simpler in rectangular form, the equation of a line, pretty simple in rectangular form, a little bit more complex in polar form, but vice versa. Circles are a little bit more complex in rectangular form, but they're simpler in polar form, arguably. Now that one does look a little weird, so I'm going to go to Desmos really quick and just confirm that those equations match. So our original line was 3x plus 5y minus 2. 3x plus 5y minus 2 is equal to 0. Okay, notice it will graph that line without me solving for y. And then my other equation is r is equal to 2 over 3 cosine theta plus 5 sine theta. I always like watching the equation or the graph change as I type in the equation there. But you can see that equation plots in the exact same place as the rectangular line equation does. Okay, so that's just confirmation of whether you did the conversion correctly.